Standard care for severe mental disorders relies on behavioral observation, taking 1 to 3 years for a definitive diagnosis. This chart illustrates the statistical cost. Misdiagnosis rates reach 50% for schizophrenia and 70% for bipolar disorder, causing years of ineffective treatment. Bypassing these subjective assessments requires an objective physiological alternative. This approach is governed by the sentinel principle. Circulating blood cells dynamically communicate with the central nervous system. Peripheral blood acts as an informative proxy for the physiological and neuroimmune shifts occurring within the brain. This data visualizes the diagnostic signature. Researchers at UC Irvine identified an 18-gene RNA expression panel capable of differentiating schizophrenia from bipolar I disorder, with an overall diagnostic accuracy of 98.3%. This discriminatory biological signal has secured an FDA breakthrough device designation. The primary barrier in precision psychiatry is no longer the discovery of these biological signals. The markers are mapped. Despite its accuracy, the assay is currently lab-bound. It requires centralized facility footprints, multi-day processing protocols, and complex benchtop workstations. Psychiatric crises do not happen on a laboratory schedule. The target clinical environment for this diagnostic tool is the emergency room, where rapid triage is essential. Translating a highly parallelized molecular workflow into a desktop footprint exceeds simple miniaturization. The hardware must provide clinical-grade thermal and physical uniformity to accurately process a sample. Moving this assay to the point of care requires hardware engineering that remains subservient to the biology, replicating lab-grade accuracy in a single patient visit. Standard point-of-care rapid tests are qualitative, amplifying a target past a minimum threshold for a binary positive or negative result. The psychiatric panel is quantitative. It relies on exact ratios across 18 targets, calculating a diagnostic probability score using a multivariable logistic regression model. Target DNA must double precisely with perfect amplification efficiency every thermal cycle. This is the butterfly effect of PCR. A mere 5% drift in efficiency, caused by minor temperature fluctuations, compounds over 35 cycles into a massive 5-fold underestimation of the starting transcript. This mathematical error completely corrupts the diagnostic score. To survive in an emergency setting, the physical device cannot tolerate any biochemical or thermal instability. Mathematical precision invalidates the drop of blood model. Fingerstick capillary blood is physically unstable. Squeezing causes unpredictable hemolysis, rupturing red blood cells and ruining transcript quantification. Instead, a standard 3 milliliter venous straw is mandatory, providing the homogeneous liquid matrix required to preserve the precise leukocyte signature. Once drawn, the sample moves to pre-analytics. Standard extraction-free protocols use heat to lyse the sample directly. These fail because whole blood contains potent inhibitors, specifically immunoglobulin G and heme, that interfere with chemical amplification. This graph illustrates the error of attempting to bypass these inhibitors through overdilution. Diluting viscous blood pushes the target transcripts below the sensor's limit of quantification, resulting in high-gain electronic noise and false outputs. The SE meter cartridge must automate a complete solid phase extraction module. Raw blood is mixed with a chaotropic agent to lyse cells. Target RNA binds to silica-coated magnetic beads, while wash buffers physically strip away cellular debris and inhibitors. Sacrificing physical separation for user convenience doomed past diagnostics. Absolute isolation is required to protect amplification efficiency and generate a clinically valid probability score. Decentralized testing faces a final logistical barrier. Standard laboratory PCR relies on fragile, frozen wet chemistry, which emergency clinics cannot reliably store or manage. The dry stabilization solution addresses this directly. Primers and probes mix with trehalose and xanthan gum to create an amorphous, glassy matrix stable at room temperature. Sensitive PCR enzymes are freeze-dried into single-dose lyobeads, allowing them to survive entirely outside a cold chain. Inside the cartridge, the eluted sample fluid interacts with these components, instantly dissolving the beads and glassy matrix to rebuild the exact assay chemistry. By embedding dry chemistry directly into the plastic architecture, the instrument delivers laboratory-grade performance independently, regardless of a hospital's logistical constraints. Processing requires precise hardware subcomponents. At the base, a thermoelectric Peltier block ensures strict thermal uniformity across 18 reaction zones. Above it, an optical imaging subsystem uses an LED and CMOS sensor array to detect multiplex reporter dice without ambient noise. Embedded firmware takes the raw fluorescence data, extracts precise threshold cycle values, and processes them through the locked multivariable logistic regression algorithm. The final output is an objective three-way differential probability score, clearly separating schizophrenia, bipolar I, and healthy controls. The marriage of microfluidic solid-phase chemistry with intense desktop biophysics creates a viable operational bridge between advanced psychiatric biomarkers and emergency physicians. Solving these biological constraints is entirely different from building a commercial device. Many diagnostic ventures exhaust their capital by attempting a bespoke hardware build before proving their clinical claims at scale. This chart outlines the SC Meters platform strategy, designed to de-risk biological variables first. Option 0 is the mandatory first step, validating the 18-gene panel as a lab-developed test on existing equipment across a large cohort. Physical hardware manufacturing and scale-up must remain subservient to biomarker validation. The capital investment must be built on a proven biological foundation. The 1 to 3 year wait for a subjective diagnosis is becoming a reality, where rigorously engineered devices provide actionable transcriptomic data in a single visit. Precision psychiatry no longer requires the discovery of new biological markers. Translating them to the clinic is now a disciplined task of biophysical and system engineering.